Hello and welcome to this spotlight talk on autonomous robots supporting software production. My name is Mark Haneide. There's lots of challenges these days in software production really. There's this massive reliance on manual labor, and this manual labor is becoming increasingly problematic due to socio-political pressures. I just need to name Brexit here, and an aging populations. So really it's not the most pleasant job going out into the farms and picking strawberries. So here we're really looking at strawberry farms, and here's an example of the way of how we grow our strawberries, mostly in the UK, on these tabletops. And we're talking here about autonomous robots like the Thorwald robot from Saga Robotics that we're working with very closely to support a number of applications to automate software production. In my talk, I will only very briefly talk about some aspects of the Raspberry project, namely really on the logistics, on the transportation of fruits, receiving it from human pickers, and also a little bit about the actual picking, autonomous picking by robots, robotic picking itself. There's a couple of challenges that we have to face. One is if we want to support human fruit pickers and we want to do the transportation for them, then the challenge is to find out where they are and to actually track them accurately to send robots where they are needed. So we have a system here where a human picker can call a robot over while they are engaged in picking, and the robot will come up, drive towards them, and receive produce from them and then do the transportation for them. So that allows us to make productivity gains of around 20% in strawberry picking, because the pickers can actually focus on the picking itself. So for that we have developed a system that exploits a topological structure and is what we call a topological particle filtering, integrating very noisy readings from GNSS systems to track exactly where people are. Integrated with that is a fleet coordination system that allocates robots to these transportation tasks using an auction-based system, and also avoids these robots getting into kind of congestion where they block each other or being blocked by other pickers, as we know the location of these individual pickers here. So I'm just going to make references here to some of these papers, and you find the references on the bottoms of the slides. And we've also now made first progress, good progress towards really autonomous picking. You would still need transportation in those sort of systems, right? There's still the overall allocation and coordination of a fleet of a farm is still needed. And so here's some work that also shows you the results of our current picking system, where we have a picking head, and the current work is really to use more clever path planning rather than the standard baseline we've got here. Here we're using probabilistic motion primitives to deal with clusters and to wiggle this head into the right position. We also use a digital twin to actually facilitate the development. Thank you very much.